Students, welcome to the third part of our fifth module. So today we will derive some relationships, some perfect gas relations in case of Rayleigh flow. In case of for Rayleigh flow, okay, Rayleigh flow. So students, first we will derive a pressure ratio. So consider a duct. Okay, consider a Rayleigh flow of a perfect gas through a duct. Then I'm taking a small control volume over this in this duct. Okay, so let this be the entering Mach number be m1 and exiting from with the m2 from the control volume. So this is finite control volume. Okay, so this is our duct. So if I am extending this control volume to a section where m becomes 1, means here thermal choking will occur, right? So that will be critical section. If pressure is p1 here, t1 here, density rho1, p01, stagnation pressure, stagnation temperature. Similarly here, p2, t2, rho2, p02, t02. And I'm just extending this duct up to a condition where Mach number becomes 1. That means the situation here is choking. There is maximum possible length, maximum possible length of the duct. Here the corresponding pressure will be P star. Since this is critical section or choking section, it can be taken as P star, T star, rho star, okay, P0 star and T0 star. Okay, so suppose I am adding a heat. If the flow is to be Rayleigh, some heat should be added or heat should be rejected. I am adding a heat Q per unit mass of the flowing fluid. Okay, per unit mass of the flowing fluid. So I'm taking this particular section as a reference section. Okay, I'm taking this because we have to non-dimensionalize, right? Pressure ratio means a non-dimensionalized form. So I will be non-dimensionalizing it based on the reference state. This critical section will be taken as the reference state. And students, we know the momentum equation P1 plus rho1 V1 square equal to P2 plus rho2 V2 square equal to what? F by A, and it will be a constant, right? So using the perfect gas equation, the definition of a velocity of sound and definition of Mach number, the momentum term, rho V square is the momentum term. Momentum term can be written as P by RT. Rho can be written as P by RT. V can be written as m into m by a, sorry, v by a, sorry, m into a, right? Or I'll do one thing, p by root, put it as v square itself. And if you multiply by gamma in numerator and denominator, it will become like this. And now this pv square, gamma rt is nothing but a square. So rho v square can be written as gamma p v square by a square, right? So v square by a square is nothing but m square, gamma p m square. So rho v square can be written as gamma p m square. Therefore, this equation will become p1 plus gamma p1 m1 square equal to p2 plus gamma p2 m2 square, right? So I will be taking p1 common, 1 plus gamma m1 square is equal to p2 1 plus gamma m2 square, and p1 by p2 will become 1 plus gamma m2 square by 1 plus gamma m1 square. So this is the equation for pressure ratio. Pressure ratio in case of a in case of a Rayleigh flow, right? So non-dimensionalizing means putting such equation into a ratio form. That is non-dimensionalizing based on based on critical section. Therefore, P by P star, P1 by P2 can be written as P by P star. Means 1 plus gamma. Here M2 will become, M2 will be 1. P2 equal to P star means M2 equal to 1, right? 1 plus gamma by 1 plus gamma M square. This will be the equation for the non-dimensionalized form based on the critical section. Now we will try to get the stagnation pressure ratio. Stagnation pressure ratio. Stagnation pressure ratio is P01 by P02, right? P01 by P02 can be written as P01 by P1 into P1 by P2 into P2 by P02. Okay. I am putting P01 by P02 into a different way. In a different way. Putting it in a different way. So P1 by P2 is already obtained, right? And P01 by P1 you know. P2 by P02 also you know. What is P01 by P1? Stagnation pressure ratio is nothing but 1 plus gamma minus 1 by 2 m1 square, right? m1 square into raised to gamma by gamma minus 1. So we have already studied in this first module. Similarly, if you write P2 by P02 is nothing but inverse. It will be inverse 1 by 1 plus gamma minus 1 by 2 m2 square all raised to gamma by gamma minus 1, right? So P01 by P02 can be written as 1 plus gamma minus 1 by 2 m1 square all raised to gamma by gamma minus 1 into P1 by P2 is 1 plus gamma m2 square by 1 plus gamma m1 square into or divided by 1 plus gamma minus 1 by 2 m2 square whole raised to gamma by gamma minus 1, right? So this is the equation for P01 by P02. If P by P0 by P0 star can be written as, instead of M2 you put 1. Okay, here M2 will become 1. M2 will become 1. So you will get 1 plus gamma. This will become 1 plus gamma. Right? 1 plus gamma by 1 plus gamma m1 square will be there. And what will be remaining here? 1 plus gamma minus 1 by 2 m1 square by gamma minus 1 will be there, and the denominator 1 plus gamma minus 1 by 2 m2 square will be 1 gamma by gamma minus 1, and you can do one thing. It will become like P0 by P0 star will become like 1 plus gamma by 1 plus gamma m1, sorry, m square will be there as it is. You make it m, because there is not here. It will become, so this term will become 2 plus, this term will become 2 plus gamma minus 1 by 2. That means 1 plus gamma plus 1 by 2, right? Gamma plus 1 by 2 whole raised to gamma by gamma minus 1. So since this is in denominator, I am taking it in the numerator. It will be inverse. So it will become 2 by gamma plus 1 whole raised to gamma by gamma minus 1 itself into 1 plus gamma minus 1 by 2 m square whole raised to gamma by gamma minus 1. So this is the equation for P0 by P0 star. Now we will move to temperature ratio. Temperature ratio. Temperature ratio for a Rayleigh flow can be obtained from pressure ratio. How? Pressure ratio along with our equation of perfect gas equation. So we know P1 equal to rho 1 R T1, right? P2 equal to rho 2 R T2, right? So you can write rho 2 by rho 1 as T1 by P1, or you can write it as T2 by, okay, T2, sorry, P2 by T2 divided by P1 by T1, right? Right? Rho 1 equal to P1 by T1, right? R and R cancels. R will get cancelled. So rho 1 equal to P1 by T1. Similarly, rho 2 equal to P2 by T2. So rho 2 by rho 1 can be written like this. So it means T1 P2 by T2 P1. T2 P1. So students, already we know the ratio for P2 by P1 is known. Okay. But we are what's our aim? Our aim is to find a relationship for T1 by T2. P2 by P1 is known, but rho 2 by rho 1 is still unknown. So we can use continuity equation. Continuity equation is rho 1 V1 is equal to rho 2 V2 equal to some G, right? G. So rho 2 by rho 1 can be written as V2 by V1. Sorry, V1 by V2. V1 by V2. But students, you know V1 by V2 can be written as Mach 1 into A1. Right? Mach 1 by A1 into Mach 2 into A2. And rho 2 by rho 1 can still be changed to another format like M1 into Mach 1 into A1 can be written as gamma R T1 by M2 into gamma R T2. Right? Gamma R T2. Here gamma r cancels. What remains is that rho 2 by rho 1 can be written as root of T1 by T2 into Mach 1 by Mach 2, right? So substitute this equation over here. Here for rho 2 by rho 1 can be written as rho 2 by rho 1 is equal to T1. Rho 2, write it once again. Rho 2 by rho 1 is equal to what? T1 by T2 into P2 by P1, right? So instead of rho 2 by rho 1, we can write it as M1 by M2 into root T1 by T2, root T1 by T2 into is equal to what? Is equal to T1 by T2 into P1 by, sorry, P2 by P1, right? Now you just try to cancel this, cancel what? Here, if this cancel, what remains is here root T1 will remain, here root T2 will be remaining. So you can write it as root of T1 by T2 is equal to M1 P1 by M2 P2. Okay. And now T1 by T2 is nothing but M1 by M2 into P1 by P2 whole square. Right? So M1 by M2 whole square, put it as it is, keep it as it is, and P1 by P2 can be substituted from the equation we have derived in the first section. Which one? Okay, this one. 1 plus gamma M2 square by 1 plus gamma M1 square. Right? 1 plus gamma M2 square by 1 plus gamma M1 square, and a whole square is this is the equation for T1 by T2. Now if you this is the equation. Now t by t star can be written as m1 by m2 will be 1. So m square into m2 is equal to 1. m1 plus gamma by 1 plus gamma m square whole square. So this is the equation for t by t star. T by t star. Now if you have to find stagnation temperature ratio, that is T01 by T02 should be found out. It can be written in another term like T01 by T1 into T1 by T2 into T2 by T02, right? So T1 by T2 already you have found. T01 by T1 and T2 by T02 you have studied in your first module. So T01 by T02 can be written like 1 plus gamma minus 1 by 2 m1 square. Okay, so this is 1 plus gamma minus 1 by 2 m1 square, and t1 by t2 is m1 by m2 whole square into 1 plus gamma m2 square by 1 plus gamma m1 square whole square into or divided by, this is actually t2 by t02, so it will be inverse, so divided by 1 plus gamma minus 1 by 2 m2 square, right? 1 plus gamma minus 1 by 2 into m2 square. So this is the equation. Now if you have to convert this ratio into based on critical section, you can write it as T0 by T0 star is equal to, if you simplify putting m2 as 1 and simplifying it, you will get 2m square plus into gamma plus 1 by 1 plus gamma m square whole square into 1 plus gamma minus 1 by 2 m square. So what I have done is m1 is m1 is taken as m, m2 is taken as 1. Okay, so and if you simplify you will get this equation. So don't worry, all this equation will be available in your data. Now we will move to density ratio. Density ratio is what? Rho 2 by rho 1. Rho 2 by rho 1 is already we have written T2 P1 by T1 P2. So both this T2 by T1 and P1 by P2 is already known. So rho 1 by rho 2 can be written as P1 by P2 is 1 plus gamma M2 square by 1 plus gamma M1 square. And T2 by T1 is M2 by M1 whole square into again 1 plus gamma M1 square by 1 plus gamma M2 square, right? Whole square is there. Now you can simply strike off this term. So this actually square term is here, this cancel, and this square cancel, this cancel, and okay, this square remains, and can write it as rho 1 by rho 2 as m2 by m1 whole square into 1 plus gamma m1 square by 1 plus gamma m2 square. Okay. So this is the equation for density ratio. So similarly, rho by rho star can be written like 1 plus gamma m square by 1 plus gamma into, instead of m2 by m1 you put like 1 by m square, 1 by m square. So that's the equation for rho by rho star. Now if you require to find velocity ratio, that is v1 v2 by v1 can be is unknown. So we know the continuity equation rho 1 v1 equal to rho 2 v2. Rho 1 by rho 2 is equal to v2 by v1. So rho 1 by rho 2 is already found out. So v2 by v1 is same, rho 1 by rho 2, it will be equal to 1 plus gamma m1 square by 1 plus gamma m2 square into m2 by m1 whole square. Okay. Similarly, v by v star is nothing but substituting substituting for m1, putting m1 as 1, v by v star is m1 as 1, so it will become 1 plus gamma by 1 plus gamma m square into m square. So this is v by v star. Now we will find, finally we will find the change in entropy due to heat transfer. Change in entropy. Change in entropy is nothing but S2 minus S1 is Cp log T2. This is the general equation, T2 minus T1 by R log P2 by P1, right? R log P2 by P1. But we already have found out T2 ratio for T2 by T1 and P2 by P1, right? And you know the relationship between Cp is equal to, how can you write Cp, or R can be written as R equal to Cp into gamma minus 1 by gamma, right? So substituting that equation, you will get S2 minus S1 equal to Cp log T2 by T1 minus, instead of R you write Cp gamma minus 1 by gamma log P2 by P1, and Cp can be taken as common, and gamma minus 1 by gamma can be Cp log T2 by T1 minus, it can be written as Cp log P2 by P1 all raised to gamma minus 1 by gamma, right? So that's the property of log, and S2 minus S1 by is equal to Cp log P2 by T1 divided by P2 by P1 all raised to gamma minus 1 by gamma. So log A minus log B is log A by B. So S2 minus S1 by Cp is log T2 by T1 divided by P2 by P1 all raised to gamma minus 1 by gamma. So this is the equation for S2 minus S1. Now you have already obtained the relationship for T2 by T1 and P2 by P1, and I'm just substituting those equations here. S2 minus S1 by Cp is log, instead of T2 by T1 I will write m2 by m1 whole square, right? m2 by m1 whole square into 1 plus gamma m1 square by 1 plus gamma m2 square whole square by P2 by P1 is 1 plus gamma m1 square by 1 plus gamma m2 square whole raised to 1 whole raised to gamma minus 1 by gamma is the right, gamma minus 1, okay, gamma minus 1 by gamma. So this is the equation for entropy change. And now S minus S star by Cp can be written as log m square into, okay, before that we can simplify this equation a bit more. How? Because these two terms are same, only exponents are different. So do one thing, put it like S2 minus S1 by Cp is equal to log m2 by m1 whole square into 1 plus gamma m1 square by 1 plus gamma m2 square whole raised to 2 minus gamma minus 1 by gamma. So 2 minus gamma minus 1 by gamma can be written as 2 gamma minus gamma plus 1 by gamma. So that is 2 gamma minus gamma is gamma is equal to gamma plus 1 by gamma, right? gamma plus 1 by gamma. So instead of this, you can write it as gamma plus 1 by gamma. Okay. So, students, S2 S minus S star by Cp can be written as log M2 by M1 is M by 1. M by 1 is M square into 1 plus gamma by 1 plus gamma M square raised to gamma plus 1 by gamma. The equation for S minus S star. So with this, we will conclude this session. We have studied various relationship, all functions like pressure ratio. Pressure ratio is written in terms of function of gamma and Mach number. Similarly, all other ratios are written in terms of both Mach numbers and gamma. So this will be tabulated in your data book. So you can solve problem without using the equation directly. You will have tabulated values. Okay. So we will do some problems in the next session. Okay. Thank you.